We're on the 2018 section B higher level. It's an intersecting planes question. Intersecting planes and oblique planes are basically the same topic. It's the same stuff that comes up. We've got four planes. We've got our coordinates. Remember, the coordinates are always over, up for the elevation, down for the plan. And then we go through. We have to draw the given elevation and plan of the intersecting planes ABC and ABD. So we're only drawing two of the planes out to begin with, and we're going to have to determine the dihedral angle of those two planes. As soon as I hear dihedral angle, I'm thinking auxiliary elevation and an auxiliary plan to show an edge view of both planes. Draw the elevation and plan of point G and determine the distance between points G and B. Distance between 2 points. In other words, you're talking a line. 2 points always form a line. I'm thinking of the distance between those. So if I have to find the distance of a line, the length of a line, it's auxiliary elevation. So an auxiliary elevation, look in at 90 degrees to show the true length. Opposite edges AE and GF of the surface are parallel, so they're parallel to the plane. Complete the elevation and plan of the surfaces AE, F and G. We'll get to that later. And then we have determined the projections of a horizontal line. Again, a horizontal line, as soon as I think of a horizontal line, it's going to be the true length in plan. If I have a horizontal line, it's always a true length in plan. Projections of a horizontal line drawn from C that will touch the plane AEFG. So as soon as I hear anything about a line or a point touching a plane, so the distance from a point to a plane or drawing a line to touch a plane, I'm thinking of the edge view of a plane. I'm going to draw an auxiliary elevation to find an edge view of this plane, and then I'll deal with the point. And I have to draw a line that is 55 millimeters long from C. We'll get to that later. Hence, determine and indicate in degrees the true angle between the horizontal line and the vertical plane. Horizontal line and the vertical plane. Vertical plane, you see it in plan. So when I look at this, I'm thinking I'm going to see this true angle in plan. I see the vertical plane in plan. The XY line is the vertical plane in plan. The XY line is the horizontal plane in elevation. So we've said that a few times. This represents two different things. Getting to the question then, the setup was straightforward. I've only drawn in the two planes that I'm asked for. I've highlighted the line of intersection. First thing we had to do was get the dihedral angle between the two. For my dihedral angle, I'm going to find the true length of the line. So I'm going to project an auxiliary elevation looking in at 90 degrees to my line of intersection. So I'm going to project off out here at 90 degrees to the line of intersection. XY line is going to be parallel to the line of intersection. I'm just going to move it up here so it misses the drawn. Now this is my X1, Y1 line. To project out my points, so for plane C, project out A, B and C, and I can take the heights from the elevation. So it's an auxiliary elevation I'm drawing. My heights are going to come from elevation. Height of point A is here. Follow point A. Height of point B is here. Again, follow up point B. And height of point C is here. I'll just move up the camera so you can see that point. Okay, so I found the plane ABC. I'm bringing up the plane AEDB next. I'm not going to bring up the 4 points. I don't need to. So what I'm going to do is I'm going to cut this plane off. I'll just show you. I'm going to take the plane ADB. So I'm just going to chop on this side off because I don't need to bring 4 points. And the reason I'll do that is that once I have 3 points, I've got a plane. So I've still got a triangular plane. I'm still going to get the same answer, and it's just going to leave me with less work, and it's going to be less awkward. So I'll project up my point for D, and it's the only point I have to bring up now because I already have AB done. So point D projected up, I get the height of D. take my height off. That gives me the plane ABD. So I've left out a portion of the other plane. That doesn't matter though, because I've got two triangular planes, and now I can project my auxiliary plan. So I come along, look along AB, so I'm drawing my projection line out along AB. I project out points D and C. And again, I'll come and set up my XY line at 90 degrees to those lines. And I'll set it up here someplace. This is my X2, Y2. And I'm drawing an auxiliary plan. I'm going to measure from plan. I'm going to measure from the previous XY line, which is X1, Y1. Again, the same thing. You can see I've got these huge distances here. I need a datum line. It's going to go off the page if I don't use it. So I'm going to take my X1, Y1 line, move it in closer to the drawing. Doesn't matter where, I can put it as close or as far away as I want. I'm going to put my datum line across here. I could even put it touching the points if I wanted to. So I'm going to take my distance for A and B. Here it is. The distances will be the same. And I project out my distance. So there is the point view of the line of intersection AB. My distance then for point D to the datum line is here. Here's my point D. And my distance for C is here. Distance to the datum line. And I get C over here. That gives me my dihedral angle because I've got an edge view of the plane ABD, edge view of the plane ABC. And I'll just highlight it in red. This is the point view of my line of intersection. Always indicate it. If it says indicate it in degrees, you show the measurement. If it just says indicate it, you can just write down the dihedral angle. It's probably safer just to measure it, so I'll quickly measure my one. And it is 104 degrees. And that's my dihedral angle. The first part to part C then is I have to find the true length of this line GB. I'll just draw it with kind of a broken line so you can see it. It's not actually part of the planes. So there's GB. Now, as soon as I hear the true length of a line, I can draw an auxiliary elevation. So I can draw an auxiliary elevation looking in at 90 degrees here. So just project off out here, set up my XY line, take my height from elevation. There's no problem doing that. I've got a second option. When it's just a line, I can actually get the line and rotate it so that I'm looking at 90 degrees to it. So when I'm looking in plan, I'm looking in here, straight in at the object. So I'm standing out in front. So what I can do is rotate that line in plan so that I'm looking directly in at the line. And if I'm looking directly in at it, I can see the true length. This would be a junior cert construction. So I can take GB. Doesn't matter which way I rotate it, I can rotate it around here or anyway, and I can rotate that line around until it is parallel to the XY line. So I come along, and now I've got a new position for that line BG. So here's my new position. We'll call that G1. So I've rotated it around. I can find the new point in elevation. So I take G1 straight up. So this is its new position in elevation. It's going to be here. Its height won't change, so I'm going to take the height across. And here is G1. And that gives me the true length of GG1. And I can label that, so you'd make sure you just label that line. There is my true length. I'd always throw a little couple of arrows in the drawing just to show what I did. in case there's confusion. Now, like I said, the other option, it's just a little bit more time consuming. I've got my line BG in its original position, so this is just a different way of finding the true length. I'm going to project out my auxiliary elevation. So I'm looking in at the line, in at 90 degrees. Project out my auxiliary elevation. I'm going to set up my XY line. So I'll put my X1, Y1 here. It's going to be an auxiliary elevation, so I'm going to measure my height from elevation. So I'll take my height of G. I could use a datum line in elevation as well if I wanted. So I've got my height of G. Take the height of G out in my auxiliary elevation. Take the height of B and project it out in the auxiliary elevation. And again, it's the same thing. That is the true length of GB. So that's just two different ways of doing the same thing. You don't have to do both. I'm just showing you both methods. I'll move that down so you can see it a little bit better. So again, projected out at 90 degrees, took my height from the elevation, as we always do. So my height for B, here was B, take out the height. Either or, the rotating method is slightly quicker. That's the only reason I showed you that. Now the second part is part C. So it says the opposite edges AE and GF of the surface AEFG are parallel. Complete the elevation and plan of the surfaces AEFG and ACG. So two lines AE and GF are parallel. If two lines are parallel, they're parallel in all views. I notice here that these lines here form a straight line. So in other words, they're vertical when you see them in the elevation. They look vertical, they're not actually vertical. And this line continues down. So I can draw that line in, and I can say AE and GF are parallel in plan, and then I can go find those in elevation as well. So in other words, take my points up, and I said they form a straight line. AE, here it is in plan, and it said it is parallel to FG, so I can parallel. It's at that point, and that's point F. Same in elevation. AE is parallel to FG, and that gives me the point F in elevation. So that gives me my plane AEFG. And I'll draw on the rest of the planes. I might actually shade them a little bit so you can see them then as well. I've highlighted up the planes with a bit of colour. Don't do that in the leave insert. Whatever you do, don't highlight your planes in the leave insert. You're covering up construction lines. I've just done it so the drawing will make a little bit more sense to you. You can clearly see the four different planes. Part D then, we have to determine the projections of a horizontal line drawn from C, which is going to touch the plane AEFG. You can break this down into pieces. In other words, if I can get a horizontal line touching plane AEFG, that's half the question done. Then I'll worry about the length of 55 centimeters. Hence, determine indicates in degrees the true angle between the horizontal line. So as I said, if you're talking about distance between a line in a plane, or distance between a point in a plane, or length of a horizontal line in a plane, you're talking edge view of this plane. So I'm going to get an edge view of AEFG. So my plane here, AEFG. If I want an edge view, I need a horizontal line. None of these lines are horizontal, so none of these four lines are horizontal. I'm going to put one in. So here's a horizontal line. I'll call that, doesn't matter, point P. So AP when I put it in. So I've got my line AP, and straight away when I come down to plan, I've got a problem because I'm trying to get the line EF and P is on it. When I bring P down, this line looks to be vertical in plan. I can't find where P is. So in other words, that's giving me trouble, meaning I can't use that line. I can take a different line though. So in other words, I'll come along and take a different line. I'll take from F. back across. So when I come across with my other line to hit my line AG, I call this point Q, for example. Now I've got a horizontal line from F to point Q. And now, because this line is at an angle in elevation and at an angle in plan, I can find it. So it's on the line AG, Q, I bring it down onto AG in plan. And here is the line FQ. So that's the line I was looking for. So again, if you go and draw a line in elevation and then you can't find it in plan, you can just take a different point on the plane, or a different line on the plane. Here's my horizontal line, I found it in plan. Now I can come along and project an auxiliary elevation looking along that line. So I'll project out here along that line. My horizontal line, I'll project out all my points, A, E, and G. XY line. And again, it's an X1, Y1 because it's an elevation I'm drawing. It's my first XY line that I'm drawing. Now, I can use a datum line here. If you look at it, the height up to G here is absolutely huge. That is going to go almost off my page. It's not going to go off my page, so you could use that line, but you don't have to. If it was going off the page, what you can do is come along and put in a datum line. Now I'm going to put it in with a blue colouring pencil just so you can see it. Don't you do that. I'm just putting it on so it stands out well. And again, you'd always label it datum. Now I've just basically subtracted this much off all my measurements, so I can take the distance to G. There's my distance for G. Distance for A. Distance for E. I haven't put the points on yet because this is going to be a straight line. It needs to be a straight line. And the distance for F. So I'm going to make sure it's a straight line. Distance to F. Here's my distance for F. The four of these should line up fairly well, and they actually do pretty good. So that is my edge view of the plane. Again, if I was asked for the inclination of the plane, here it is, the inclination. But I was asked for a horizontal line from C, so I have to go and find point C as well. And remember, it's off the datum line also. Here's point C. And sorry, I'll project it out here. Point C comes out. And I take my height. So remember, height of C, taken from the datum line up, take out point C. Now, a horizontal line will be parallel. So if you look at my horizontal lines, these little two lines I drew are horizontal, parallel to the XY line. The same rule applies when I'm drawn in an auxiliary elevation. If it's a horizontal line, it's parallel to the XY line. So a horizontal line here, I can draw parallel to the XY line. I come across, and that's telling me that a horizontal line drawn from C hits the plane at that point. That's about half the question done. It doesn't fully give me the solution yet. I'll zoom in a little bit so you can see better. Okay, so I've zoomed in. I've drawn my horizontal line that hits here. Now this could be any horizontal line. That could be a load of different lengths. I haven't given it a length yet. When I bring that point back in, so I bring the point back into my plan, the point I'm looking for is somewhere here, but I don't know where. So as I projected it back in, and it's going to be somewhere along this line here, but I don't know where. It said it was going to be 55 millimeters long, and because it was a horizontal line, I'll see the length of it in plan. Now this is an awful hard question. I wouldn't be expecting people to get this. Length of 55, the length of the line, and I'll have two options. If it hits, it won't hit this side, so it's actually one option. I've set 55 in the compass. measured from C, and the length of the line is here. So my distance 55 from C to cut the line, that is the projections of the line in plan. So that is the line I'm looking for. Don't forget to draw an elevation, and when I draw an elevation it should be horizontal, so that is going to tell me whether I'm right or wrong. So when I bring my point up to elevation, when I come across, it'll be a horizontal line. There is my horizontal line in elevation and my horizontal line in plan. The last part it said was indicate the angle between the horizontal plane, the vertical plane. Here's the vertical plane in plan. Here is the line extended. So in other words, my angle between the two is this angle here. And again, for safety, you'd measure it. Now this in the leaving cert would only be worth a couple of marks. So it is 56 degrees, as I have it. That is your question complete. Sorry, I stayed zoomed in on the elevation. When I drew my projections, brought the point up, and it was a horizontal line. So here's my horizontal line in elevation. That's the line in elevation, that's the line in plan. That is the question complete.